So we're now switching gears from informal logic, and we're going to now look at formal logic. And with formal logic, we get worried about the structure or the form of arguments. And we're first going to look at categorical syllogisms. So we're going to be worried about the structure of how categories are being related to one another. And based on how they're being related to one another, we'll either have valid arguments or invalid arguments. And we'll cover the categorical syllogisms in a great deal of detail. Once we're done with that, we're just going to get our feet wet just a little bit in examining propositional logic. And in propositional logic, for now, all you really need to know is that propositions or statements take up the basic units. So we're looking at statements as opposed to categories. And then given the type of logical operators or connectives that we use with those statements, we'll see that we'll be able to tell whether an argument is valid or invalid. So categorical syllogisms are arguments that are composed of categorical propositions. So first we need to talk about categorical propositions as we start investigating categorical syllogisms. And a categorical proposition is just a proposition that relates two classes of things. So the example that I have here is that some individuals are single. What we're doing is we're saying that a certain relationship obtains between the class or category of wealthy individuals and then the category of single individuals. Later on, we'll talk about precisely what we are asserting when we maintain that some wealthy individuals are single individuals. But for now, what I want you to see is that we're saying that there is some sort of relationship that obtains between these two classes. So in contrast to a just regular run-of-the-mill categorical proposition, we have what's called standard form categorical propositions. And we make these because what they do is they express the relationship between two classes with complete clarity. That way, we get rid of any possible ambiguity that can happen in ordinary language when we don't have a standard form. When analyzing categorical syllogisms, we want to make sure that we're not going to fall victim to any ambiguity. So we want to be able to put any categorical proposition into a standard form. And what I have here is the schema or diagram for doing just that. So in the standard form, our sentence or our proposition will always start with a quantifier. And there's only going to be three quantifiers that we have at our disposal: all, no, and some. So if you come across a categorical proposition that says every whale is a mammal, then we have to realize that that needs to put it in standard form, that says all whales are mammals. Then we'll have a subject, which will be a term of some sort. The example I just used had whale as its subject. The copula is what connects our subject and our predicate. It couples them together, and it'll be a form of to be. And our textbook stipulates that we'll only be using two copula, are and are not. Which means that this is going to have to be plural. Our subject term will have to be plural. So all whales are, and then our predicate will be a term, and we said mammals. So when we put categorical propositions in standard form, it's always going to take the quantifier, subject, copula, predicate form. Always going to follow in that order. So the schema gives us 4 possible categorical propositions in standard form. And the convention is to associate each of these categorical propositions with a letter. So A gets associated with all A or B, where A is our subject term and B is our predicate term. E propositions take the form no A or B. I propositions take the form of some A or B. And O propositions take the form of some A or not B. So if we have a categorical syllogism, if we're given a categorical syllogism, and the propositions in that syllogism are not in standard form, what we have to do is reflect on the meaning that's being conveyed by that categorical syllogism and figure out how to put it in this form and keep that same meaning. That is not that change that same meaning. So let's practice identifying the parts of a categorical proposition. So if we look at this sentence, some voters are persons who are not informed, think about which part is the quantifier, which part is the subject term, which part is the copula, and which part is the predicate term. Our quantifier is the word some. Our subject term is voters. The copula is are. And our predicate term is the entire phrase, persons who are not informed. Some of you may have thought that are not was the copula. The reason why you would be wrong is because are not is contained in a clause, namely who are not informed, that is modifying persons. So it belongs to the predicate term as a whole. And it's really these two categories that are being coupled together, that's being related. So now we can ask ourselves, well, what kind of proposition is this? Well, we had A, E, I, and O. This takes the form of some A or B. Which tells us it's an I proposition. Now let's look at this next one. Some individuals who are tall are not basketball players who are famous. So again, we want to determine the quantifier, the subject term, the copula, and the predicate term. Again, our quantifier is going to be the word some. Our subject term is going to be individuals who are tall. And that's because who are tall is modifying our grammatical subject. So this is not our copula, since it belongs to the subject term. Instead, it's are not. And our predicate term is basketball players who are famous. Again, this clause, who are famous, is just modifying our grammatical predicate. predicate or grammatical object. But really, it's these two categories that are being related to each other, that are being coupled by our copula are not. The structure of this proposition then is some A are not B. And that conforms to O propositions. So it's an O proposition. Let's think about what it is we're committing ourselves to when we are dealing with these standard form categorical propositions. So what are we saying? What are we expressing? What do they mean? If I say all A are B, I'm saying everything that's an A is also a B. Or in other words, if members of A exist, they are members of B too. Notice that we're not saying that members of A do exist. Rather, if they do exist, then they're going to be members of B as well. So when I say all A are B, I'm saying that the category of A fits completely within the category B. On the other hand, if I say no A are B, I'm saying that there is no overlap between the category A and the category B. There's no members of one that are also members of the other. So if members of A exist, then they are not members of B. If members of A exist, then they are not members of B. Again, we're not committing ourselves to the existence that A's do in fact exist, that there are members of A, but rather, if they do, they're not also going to be members of B. Now, when we get to these two statements that begin with some, these two categorical propositions that begin with some, we are committing ourselves to the existence of something. So we say some A are B. That means we've committed ourselves to the existence of there being an A member of A, and it's also a member of B. So there is an overlap between A and B, at the very least an overlap, and there is at least one member that belongs to both of those categories at the very same time. If I say some A are not B, then what I'm saying, again, committing myself to the existence of an A, so there exists at least one member of A, and there's at least some non-overlap between A and B such that this member belongs to that non-overlap, wherever that is. Right? So it's going to be something that's in the A category but outside of the B category. Now we're going to turn our attention to properties that categorical propositions have and that their terms have. So the properties of quality and quantity are properties that the categorical proposition itself has. And then we're also going to talk about distribution. And distribution is a property of a categorical proposition's subject and predicate terms. All right, so let's give ourselves a little bit of an overview of our properties of quality and quantity and distribution. So we say that for our proposition, our A propositions, get a different color here. So our A propositions, all A are B, is affirmative because our quality comes in two types. It can be affirmative or negative. So if we say all A are B, we're affirming that A's are all in B. But if we say no A or B, we're denying that A's are in B. So it's negative. Again, some A are B. That's going to be affirmative because we're affirming of at least one thing that is an A that it's also a B. But if I say some A are not B, then I'm denying I am committed to the existence of an A, but I'm denying that it's in a B. So it's negative. I think the notion of quality is probably pretty intuitive. It's probably fairly clear when a statement is affirmative or negative. When we move over to quantity, what we're worried about is how many things we're making an assertion of. If we're making an assertion of everything, then it's universal. So when I say all A are B, I'm saying of everything that's an A, it's in a B. It's in the category B, rather. And when I say no A are B, I'm saying of every single A, none of them are going to be in the category B. None of them are going to be B's. So when we say all A or no A are B, we're dealing with universal statements. In contrast to universal statements, we have particular statements. And that's when we're saying of at least one thing that in this case it's a B or not a B. So when we're dealing with the words some, we're going to be dealing with particulars. So the property of distribution is a little more complicated than that of quality and quantity. And whereas quality and quantity were properties of the proposition as a whole, the categorical proposition as a whole, distribution is a property of the terms in the categorical proposition. So we're worried about whether the subject is distributed and whether the predicate is distributed. And of course, in all of our cases here for our A, E, I's, and O's, the A's will be our subject terms and the B's will be our predicate terms. So we say that a term is distributed when the categorical proposition makes an assertion about every single thing that term denotes. So if we say all A are B, we're asserting of everything that is in the A category, it's within the B category. So we've said something about all A's. We've committed ourselves to something about all A's. And because we committed ourselves to something about all A's, the subject term is distributed in this case, right? Because A is our subject term. Of course, we don't know that from the fact that all A's are B's, we don't know whether all B's are A's. There's the possibility that there's something that exists within the space between the A's and the B's. Thus, the predicate term, in this case B, is undistributed. Now, if we look at our E proposition, no A are B, then we're committing ourselves to the category of A and the category of B being completely separate such that there's no overlap whatsoever. There's no overlap here. Which means we've committed ourselves not only that for all of the A's, none of them are going to end up being B's, but we've also committed ourselves to, for all of the B's, that none of them are going to be A's. So we're saying something about everything that falls under both the subject term and the predicate term. So for E statements, both the subject term and the predicate term is distributed. For I statements, all that we know is that there must be some overlap between A's and B's. Because there's at least one thing that exists in that overlap. We've committed ourselves to that. But we don't know if all A's are B's or if all B's are A's. So we don't know anything more than just about this one thing. So both of our subject term and our predicate term are undistributed in I statements. But for O statements, we're told that there's something that exists that's in our A category, so just let the A be outside of the B. And it's not a B, which means we know of all of these B's, they're not this A. So in O statements, our predicate gets distributed, but our subject does not. So for a recap, we have the properties of quality and quantity, which are properties of categorical propositions. There are two kinds of quality: affirmative and negative. So a proposition can be either affirmative or negative. And it's affirmative if it's making a claim about class inclusion. It's negative if the claim is a denial of some class inclusion. For quantity, we again have two possible properties. It can be universal or particular. A categorical proposition is universal if the proposition makes a claim about every member of the subject class. Whereas particular categorical propositions make a claim about at least one member but not all, but at least one member of the subject class. Distribution, we said, is a property of terms in the categorical proposition, not the categorical proposition itself. And a term can be distributed or undistributed. A term is distributed when we've committed ourselves to something about every member of the class in question. So if the proposition commits us to something about every member of the class in question, then that term is distributed. If it does not do so, then it's undistributed. So let's look at a couple of exercises. Here we have a categorical proposition. Some markers are smelly objects. We need to identify what kind of categorical proposition that is, A, E, I, or O. And then we want to rewrite the proposition, but changing the quality and keeping the quantity the same. So changing only the quality. So think about those two questions for a moment, and then I'll give the answer. The proposition that we have here is an I proposition. And if we change the quality, then we need to change our proposition to from an affirmative to a negative proposition, and that's all we're changing. So this would say some markers are not smelly objects. And that would be the correct answer. So now let's look at this second categorical proposition that we have. No zebras are disguised mules. Again, we want to identify the kind of proposition, and then we want to change the quantity, but keep the quality the same. This proposition is an E proposition because it has the form no A or B. The quantity of this proposition is universal. So if we change the quantity, we need to go from a universal to a particular. But remember, we're keeping the quality the same. And since no zebras are disguised mules is a negative proposition, then the particular proposition that we come up with needs to also be negative. So this is some zebras are not disguised mules. We went to a particular, but we kept it negative, just like the original categorical proposition was. We want to change both the quality and quantity after we've decided or determined what kind of proposition it is. So do both of those things. So the proposition that we have is an A proposition because it takes the form all A are B. And if we're changing both the quality and the quantity, then we need to move one from a universal statement to a particular statement, because this is a universal statement. It's also an affirmative statement, so we need to move from an affirmative statement to a negative statement. So now we have, what we should be left with is a particular negative statement. And particular negative statements take the form of O statements. So our proposition that we're left with will be some knitting projects are not projects for geniuses.